All right, I think we have most of us here, so I'm going to go ahead and get started. So welcome everyone to the possibilities of personalized medicine. My name is Emily Hostetler. My pronouns are she, her, and I'm an educator here at the Museum of Science. Thank you all so much for tuning in tonight. Let's begin with some logistics. So if you'd like to see captions today, please click on the closed caption button and select show subtitle. We will keep all participants' audio and videos off for the duration of the panel discussion. If you would like to submit a question for our panel, click the chat button at the bottom of your screen and send in your questions to me, Emily Hostetler, and I'll forward them over to our moderator. Janine, you can go ahead and stop sharing your screen. After the panel today, you will have the opportunity to move into small breakout group conversations to dive a little deeper into what was discussed. If you choose to stay for those conversations, we will be offering you a $25 e-gift card as an appreciation of your time with us this evening. I would like to take this time to thank the Tufts Clinical and Translational Science Institute for being such a fantastic partner and collaborator on this project, along with the rest of the Museum of Science team who made this program happen. And also, I would like to thank the National Institutes of Health and the Lowell Institute for supporting our program tonight. Now, I would like to turn it over to Dean of Tufts CTSI and Executive Director for the Institute of Clinical Research and Health Policy Studies, Harry Selker, who would like to welcome all of you here tonight. Go ahead, Harry.
Oh, thank you, Emily. Yes, I'm Harry Selker, Dean of the Tufts CTSI. And I just want to welcome our participants to this Museum of Science Forum, The Possibilities of Personalized Medicine. We are all interested in this rapidly advancing technology to tailor medical treatments based on genes and other personal characteristics. And this promises to be a very stimulating and informative panel and conversation that we will have this evening. I'm delighted that we get to collaborate with the Museum of Science on these science communication dialogues, and I very much appreciate the participating of these outstanding speakers and staff reporter Angus Chen, who will moderate and introduce these speakers. Finally, besides the eminent speakers and moderator, I want to thank the science communication team that organized this, the Tufts CTSI and Museum of Science staff who worked so hard to make this event happen. And also I want to thank all of you who have taken the time this evening to participate. I'm sure it will be a very rewarding forum. Thank you very much for joining us. Emily?
Thank you so much, Harry. Our partnership with the Tufts CTSI has been an incredible opportunity, and we're so grateful for all of the people on that team who helped make this event possible and all of our events that we've done so far and might do in the future. So thank you so much for being here, and thank you so much to Tufts CTSI. So before we begin our event tonight, I would like to remind you all to keep your issue guide handy that we sent out to you, just in case you would like to look up a term you're not sure or you want to know more about. Similarly, there are a few different understandings of how personalized medicine is defined. So to make sure we're all on the same page, here's how we're using the term tonight. When we refer to personalized medicine, we mean customizing ways of treating or preventing disease on the basis of differences in a person's genes that determine particular characteristics that they have. This customization is possible because of advances in technology, mainly through genetic testing that allows personal information to be translated into measures that help predict disease, outcomes, and risks. Medical care for the individual is usually understood to be personal, which is why people in the field often prefer the term precision medicine. This all might seem a little new right now, but we hope that you'll learn a lot more during our conversations tonight, and you can ask any questions that you have. So now I would like to get us started, and I'd like to welcome our moderator, Angus Chen from Stat News, who will begin our panel discussion. Thank you so much, everyone.
Thank you, Emily. As Emily and the Museum of Science just introduced me, I'm Angus Chen. I'm a reporter at Stats. So excited to be here. We have three great panelists. The first that I'm going to introduce today is Latrice Landry. Latrice, you can turn your video on. Latrice is a biomedical informatics postdoc at Harvard Medical School. And our next panelist is Crystal Sosi, who is a PhD candidate in genetics and bioethics at Vanderbilt University. Crystal, please turn your video on. And then we have Jill Moran, who is the pediatrician in chief at the Women and Infants Hospital of Rhode Island. Jill, thanks for being here. So I guess I'll have each of you say a little bit about what you do, maybe one sentence, and then we'll get to some really exciting questions that we have for the three of you. Jill, why don't you start?
Thank you, Angus, and thank the Museum of Science and Tufts CTSI for having me. I'm a neonatologist, meaning I take care of critically ill, premature, or newborn babies, and I conduct research on integrating whole genomic sequencing into this population.
Thank you. And Crystal, why don't you tell us a little bit about what your work is like at Vanderbilt University?
Well, actually, thank you for the invite. I'm transitioning out of Vanderbilt and transitioning to Arizona State University as assistant professor, but my major line of work is as a co-founder of an Indigenous-led biological and data repository. Our central premise is that data that's collected from Indigenous peoples should be housed locally so that it is governed and stewarded by Indigenous peoples, especially if we want to talk about benefits of health for Indigenous peoples.
Right, of course. Congratulations at your position at Arizona State University. That's fantastic, and I'm sorry I forgot about that. Latrice, could you go next?
Hi, I'm Latrice. Hi, I'm Latrice Landry. I'm a clinical molecular geneticist and molecular epidemiologist. I interpret genetic testing for patients, primarily that is around cancer and sort of rare diseases. And my research focuses on how we build equitable systems within personalized medicine, and specifically around genetic and clinical genetics for diverse populations to all benefit from personalized medicine.
Thank you. So Emily gave us a really great bit of background on what personalized medicine is. And I wanted to ask the three of you, if you could give us some powerful examples of personalized medicine, and what are some of the important things in personalized medicine that you see playing a really big role in how this is going to look in the clinic in the future? And Latrice, since you went last, why don't we go with you first?
Great. So I have two examples that I think that are primed for the pump, and some of them are already sort of at play for personalized medicine. One is a cancer example. So routinely now, when you are diagnosed with cancer and specific types of cancer, you may be offered a panel test, which will test your tumor to see if there are molecular markers that are associated with targeted treatments. So essentially, your tumor gets a gene test with markers that are associated with treatments that have been developed to target those markers and therefore improve outcomes. And this is different than the standard care, which might be chemotherapy. The other, I think, space where precision medicine is really moving is this idea of sort of in personalized medicine, so this idea of how we implement it in public health. And one of those examples is in the area of familial hypercholesterolemia, which is a rare disease. However, it's a fairly common rare disease, and it's essentially, in its name, high cholesterol. And essentially, there are about 3-4 genes that are commonly thought of causing familial hypercholesterolemia. So the idea here is that someone has a gene that may cause them to have really high levels of cholesterol. If we can screen them before they actually have illness and tell them that this is the case, their primary care physician could have this knowledge, we can treat and prevent severe outcomes from the disease. And so there are current programs being developed and put in place to screen populations for these rare variants for this disease of familial hypercholesterolemia.
Sounds really exciting. So Crystal, are there any sort of examples of personalized medicine that you see coming up in your work that sort of gets you really excited about this field?
So I actually take a little bit of a cautionary view about the term personalized medicine or even precision medicine, because these terms have been used almost interchangeably, but have also evolved since they were first entered our lexicon more than almost 20 years ago, when we had the promises of the completion of the human genome and its implications on our health. And definitely the working definition that was provided earlier is sort of the central definition that is used for precision medicine, but there are also detractors that I think is important to acknowledge in this space, that precision medicine is an imprecise term. What we're actually talking about here is particularly in terms of grouping individuals into likelihood risk categories using genetics, we're not really talking about precision medicine in this domain. We're really talking more about stratified medicine. And when those strata are defined along race and ethnicity categories, then really precision medicine becomes more in line with racial medicine. And this is something that we really have to be cognizant of, especially as we are entering into communities that have been underserved, that we're not perhaps over-promising on something that precision and genomic medicine cannot deliver. Now, my line of work is working with Indigenous communities, and Indigenous peoples have always been sought after for our population-specific genetic variation. Indigenous peoples historically have not participated in genetic research. And therefore, and those are reasons sustained due to like distrust of the research and researchers, but then there's also concerns about co-optation and commercialization of our genomic information, which is something that is important to be aware of, especially as genomic data sets are becoming increasingly accessible to pharmacogenomic research and also companies. So there is it an intrinsic value and sometimes a commercial value related to genetic data from diverse data sets like Indigenous peoples, particularly as we're talking about what are we missing in terms of what our understanding is about diversity related to genetics. And there is a huge interest in increasing the recruitment of Indigenous peoples in genetics, but we also have to caution, is this interest for our benefit or is it for other people's benefits? So in terms of what I do in terms of working with communities is that I want to ensure that communities are engaged during the process, that they are entering into research on equitable terms, and that they are able to understand not only what the value is of the genetic information that they're providing, but also that they have, the Indigenous communities have data sovereignties related to their data. So that if we are going to develop technologies that are specific to population-specific variants from Indigenous communities, that we ensure that Indigenous peoples benefit first. And I'll leave it there at this point, since I know we have plenty of opportunities to talk on this point later. Thank you.
Yeah, absolutely. And I think that's a great segue into our first topic of tonight. But I do want to ask Jill a little bit about what you see in personalized medicine, and sort of how, like, any examples of personalized medicine that you're working with or you're excited about, and how you might see that affecting patients.
Sure. So one of the benefits that we've seen in newborn medicine is how we can use these emerging platforms to really diagnose much more quickly, our very sick infants. So traditionally, when we took care of infants in the neonatal intensive care unit that we suspected of having a genetic disorder, but using the more traditional diagnostics, were not able to make a diagnosis, these infants would linger sometimes for years without a diagnosis. And over the last 5 to 7 years, we have been able to integrate genomic sequencing into this population with really tremendous success. And the personalized part comes in the fact that although we can sequence all of their DNA, we only focus on that baby's symptoms when we analyze it. So we use the baby's clinical presentation to very rapidly interrogate their own DNA to understand what could be leading to their illness. And in so doing, we have cut what was formerly years of a diagnostic odyssey literally down to days. And that has made a significant impact in their care, because now we can know what to treat them with, potentially redirect care, either to a life-saving or a life withdrawing measure if it is a fatal disorder. And this has allowed us to really transform how we care for our most critically ill babies in the NICU.
Yeah. So, I mean, clearly we're hearing that personalized medicine covers an incredible range of things. And I'd love to ask the panel how you see I guess like what kinds of data go into personalized medicine, and what is the sort of the best way to sort of conceptualize this idea? Is it just like we're taking someone's DNA and sort of basing it on that? Is it based on where someone lives maybe, or how old they are? Like what is it like? What's the best way to sort of think of this idea? Whoever wants to who feels comfortable taking this.
So I would say, Angus, the way I think about personalized medicine, precision medicine, I'll just say that early on in 2015, I think there was a conversation where a lot of physicians said, well, all medicine is personalized. And so ultimately the term precision medicine got implemented with the precision medicine initiative because of that point. So I will say they are conflated quite often, but the concept of the two where they overlap, I think, is really not meant to be a precise term, but more of a big idea, right? And it is a big idea, and I think as Crystal was mentioning, sort of the idea, as hopeful and inspirational as it may be, is fraught with a lot of pitfalls. And I think that to your question of what is the data goes into it, I think that's why it's fraught with pitfalls, and why we need to be vigilant at this moment, and why vulnerable communities have a lot of concern for precision medicine or personalized medicine. So what data goes into it? I think of personalized medicine as this idea that we're going to have customized knowledge bases based off of biomarkers and maybe algorithms, maybe wearables, things that you, any kind of data that might be specific to you, and would be grouped in different ways, but that's sort of how we classify algorithms in a sort of informatics necessity. We sort of classify and group things together. So we have certain biomarkers that we determine are associated with certain things, and therefore we can use those markers to think about your individual or personalized risk, right? And so we're taking a customizable knowledge base and applying it to your individual care. And I used to have a professor who thought about it as shoe sizes. So the idea isn't to get to individualized care, but like it used to be a time where everyone got their shoe fit to their actual foot. And that's not what medicine can offer, but what it may be able to offer is a shoe size that generally everyone is able to find a shoe size that fits their foot. And so I think that's the idea of it. And I think that that's the data that's meant to go into it. These biomarkers, other types of data, could be technology, could be sort of things that are collected about you that can impact our knowledge about disease and disease risk, and could be used for your care. I will say, though, that the issue here, and I think from my research, is the goal, the inspiration to be inspirational for people like me and for the communities that I represent, is that we need to make sure that we build facilitators to help us achieve that goal for all. As it exists right now, there's a lot of, and again, it goes to the pitfall. So I liken this because of the time of the year we're at, and just a quick little anecdote. So it's like Thanksgiving, right? And so the idea or the promise of personalized medicine right now is that I'm inviting you for Thanksgiving dinner, and I ask you what you want. And, maybe Crystal says, I want turkey. And she tells me how she likes her turkey. And I'm like, okay, I'm going to get a fried turkey because that's what Crystal suggested. And then Jill tells me that she really loves stuffing, and her grandmother has a special recipe for stuffing, and she shares it with me. And I'm like, oh, I got it. And then Angus says, well, he grew up with his little sister used to, and he used to make cranberry sauce, and he really loved doing it together, and he used fresh cranberries, and it was a family. And so I invite you all over, and I take all these special things, and you come and sit at my table, and Angus sees the cranberry sauce made just like he said. A picture he showed me, it looks just like that. And Jill sees the stuffing, and Crystal sees the turkey, and everyone's excited to eat. But then we sit down at the table, and only I'm able to eat. When Angus cuts into his cranberry sauce, it tastes just like cauliflower. Now, I'm a nutritionist, there's nothing wrong, but it looks like cranberry sauce, but it tastes like cauliflower. It's not cranberry sauce. It's not what he wanted. And then when Jill tries to sort of, and Crystal tried to jump in, it's actually plastic. It's just a look, it's just there. They're not able to tap into it. So we're inviting everyone to sit at the table. But right now, the evidence base doesn't allow us, and the mechanisms and the infrastructure around personalized medicine doesn't allow everyone to eat in this great vision of sort of what our Thanksgiving dinner is going to be. And there's problems with that, right? So there's a distrust that quickly comes when I invite you to eat. I ask you what you want. You sit down at a table. You're ready to participate. You're ready to join. You contributed what you were told to contribute, but yet you're not able to have an equal footing. You're not able to enjoy the meal. And so I'll leave it with that.
Yeah, I think that's a really interesting analogy. And it kind of gets to this idea that, personalized medicine is incredibly powerful, but powerful for whom? Like, especially with the data that we have right now. I think this is something that you've looked at, right, Latrice, in some of your work, the way that our current structure of personalized medicine can exacerbate certain health inequities. Could you talk a little bit more about that, or if you have any examples that you could give in the real world?
Yeah, so one of the things I was quickly asked when I was just proposing that there might be some issues that as we try to scale for all populations was prove it, right? And so we did. We started to look at the evidence base, and consistently other groups have looked at it. And it looks like for whatever disease area you're looking at, the general knowledge around human genetics and disease centers around 80% European. For some diseases and some applications, about 90%. When you break that down by translational research, I'm thinking about an entire framework for how we think about biomedical research, from discovery to sort of validation of utility and validity of individual biomarkers, all the way to implementation on a population level. It gets even worse. So one of the things as you think about discovery, there's a lot of disparities in the research that we've generated. So our knowledge base around biomarkers is biased, but it's even more biased when you think about implementation or clinical studies that have actually looked at the validity and utility of certain targets now, therapeutic targets, or even clinical tests that are developed through that same framework. And so when we think about it across the translational research framework, we have disparities in our evidence base that don't allow us to know how generalizable our biomarkers are, don't allow us to know if they're valid or have equal clinical utility for all populations, and don't allow us to know if there are barriers to access and implementation that might sort of be a part of a public health strategy for a clinical implementation. And so we've seen this for diseases, disease by disease, and we've demonstrated this issue. And so it becomes a real clear issue of how we target not just discovery, because there's an economic value in increasing discovery. As Crystal alluded to, certain populations will be targeted because there's interest in discovering new drug targets or new therapeutic targets. But there's also the issue of whether we know things are clinically useful for all populations. And one of the hallmarks of this is this area of polygenic risk scores. I think it couldn't be more clearly stated. MIT Technology Review published an article a few years ago, said white-only genetic testing show how biased research has become. And so essentially polygenic risk scores are based on population backgrounds, identify markers that don't individual have associations with disease, but the collection of the genetic architecture and markers across someone's genome are in sort of process of being shown to be associated with disease. However, the genetic architecture is very population defined, and so we find it's very difficult to generalize the polygenic risk score that's only been developed in a single population, which right now would be Europeans, to ensure that it's generalizable to all populations. They don't perform the same way as you try to translate them to different populations. And so companies were developing these scores because they had lots of data. They felt like they had sufficient evidence to have this algorithm to tell someone their risk for breast cancer, tell someone their risk for cardiovascular disease. But the caveat was the test was only limited to white-only patients. So a physician or a clinician of any type, genetic counselor, was told that they could only offer this very valuable, you are at risk for breast cancer given your background architecture, only if you were white. And so that was creating this white-only test, genetic testing. So I think it's a part of polygenic risk scores. It's probably most exemplified by that, but it's inherent in almost all of the research, because personalized medicine, precision medicine are supposed to be evidence-based. And so the lack of a generalizable evidence base is putting us in a very precarious situation.
Yeah, I mean, I think one question someone might have when hearing this is, well, if it turns out that white populations are the ones who seem to be participating the most in these studies, it makes sense that they might be the most to benefit per se. But that's really a very simplified and almost a sort of a rewritten narrative, it feels. It leaves out really sort of a very important part of the story, doesn't it? And so I want to ask Crystal, I think this sort of maybe falls a bit into your realm of expertise. What are some of the reasons why minority communities don't contribute as much, or what is sort of creating barriers to their ability to participate in some of the study and benefit from it?
Sure. I wrote a paper recently in which I sort of highlighted the perhaps disparaging messaging that we as geneticists sometimes provide when we perhaps overpromise or oversell the benefits of precision medicine. And just speaking it from somebody that has attended a number of meetings in which researchers have been interested in forging connections and with Indigenous communities, that a lot of times what ends up happening is that the central message that researchers provide to Indigenous communities is something to the effect of, well, if you don't participate in this genetic study, then your people are going to miss out on the benefits of the research. And when you think about it, though, there are a number of historical and current reasons why Indigenous peoples choose to not engage in genetics research. There are a lot of power imbalances that are at play, that still are currently at play, related to the unidirectional exchange of data, such that providing that type of messaging that people will miss out on the benefits without changing those power dynamics that cause that sort of disengagement to begin with is a form of victim blaming. It's also coercive if it's not done in a truly cognizant and sensitive fashion. We also have to question that there is a huge power dynamic in that a lot of the research that is and data that's collected from researchers benefits research and researchers. It's almost a conflict of interest in that the agents that are benefiting the most from the research are also calling the shots, and they're dictating the rules of research and what constitutes what can be classified as data or like human subjects data and what is constituted as non-human subjects data. And a lot of this, it feels like, is to usurp data governance away from communities, especially as we're thinking in terms of not only are we just collecting the genetic data, but we're also harmonizing the data and collectivizing into increasingly larger data sets that enables us to have the ample power or statistical power to detect associations to inform algorithms that become these sort of predictive tools that were just mentioned.
Quickly, I just want to ask if you could define what this term that you use, data governance. What does that mean, and why is it important to keep that in the hands of the community?
No, that's a great question. So we really want to think about in terms of who is dictating and defining and who's stewarding the data that's being collected from individuals. Traditionally in the past, it was considered a standard of the field that researchers almost had like a sense of ownership over the data that they collected and procured from communities, such that there have been a number of controversies in North American indigenous communities, and that researchers have entered their nations and after collecting blood and samples from the peoples, they felt like it was their data to do whatever that they wanted to do with. And they would even travel across international borders and share it with other researchers without informing the community what type of research they were doing and conducting with this. This actually resulted in a seminal lawsuit in which the Havasupai Nation sued the Arizona Board of Regents for violations of trust related to overuse of broad consenting of their samples. So in this case, an Arizona State University researcher wanted to replicate findings related to a type 2 diabetes association in this community. And, what they ended up doing is they started using the individuals, the people's samples to study other things like schizophrenia and population migration theories, and using words like inbreeding, even though this is a community that exercised exogamous marriage culturally. And these the community just felt like they had misplaced their trust in researchers. There has been also instances in which U.S. indigenous communities have chosen to exercise their sovereignty or their federal recognized right to self-govern and have by and large chosen not to partake in genetic studies. So there seems to be like this huge gap of knowledge in the actual true indigenous genetic diversity in nations in the US. But then what ends up happening is we see a number of genetic studies coming out of countries south of the US border in Central and South America, and occurring in countries in which their colonial governments don't exactly acknowledge the individual's rights to even exist. So in this case, we have concerns in which US and European researchers who obviously have the money and the means and the interest enter these disenfranchised communities and collect the data. This is what happened actually in a large scale diversity project that started in 1994 and on through 2005 plus, is they collected indigenous samples from groups in central Amazonia and also Mexico, and made the data openly available for the purposes of benefiting all of humankind in research. And these data sets, because they are open to individuals, were also accessible to companies. And now, like if you purchase a test from like 23andMe or Ancestry DNA or these other genetic ancestry tests, and you get an estimate of indigenous ancestry, those informative markers come from those individuals that were disenfranchised in Central South America. And the amount of commercial interest is huge. Ancestry was sold for like $4 billion to a venture capital firm a couple of years ago. And before that, they were making over $1 billion in profit every holiday quarter from individuals wanting to gift genetic ancestry tests for Christmas. And the number one question that Ancestry had for a while was like, why is my Native American DNA now, or why is my Native American ancestry not showing up? There's a huge link of interest of people who may not understand that indigeneity is not linked to biology, and it's perpetuating this conflation of biology and also identity. And this comes into very sticky issues, in that many geneticists, even today, some really high recognized geneticists have been lambasted by social scientists and anthropologists who have studied the interplay of genetics and also race. That some top tier scientists have gone into some hot water for their for perhaps overconflating and misinterpreting or misrepresenting how they're actually using genetic ancestry estimates in the study related to health, and perhaps mischaracterizing the connection to race. What exactly was the original question? I'm sorry, I kind of went.
No, I was asking about data governance, but I think I mean, part of what you were saying, I think, is really, really fascinating, in that the way the power of the sort of who's in control of this data is being controlled not by the people whose data this, who are the originators of this data, that we might say, the people who are participants in this study, but rather like more powerful corporations or researchers. It's interesting about who kind of gets to make that decision. And to actually complicate this idea of maybe data governance a little bit more, there's, I guess, an area of personal medicine where there's a population that actually cannot consent, or is not currently able to consent to who is control of that data, and who should be maybe controlling that data in the future, and that's children. And so, Jill, this was something that you've looked at in the past, something that you've encountered with your work, that when personalized medicine comes to sort of neonatal care or pediatric care, there's a question of how does one manage that data for the child when they cannot consent for themselves, how they want that data to be managed. So I wonder if you could talk to that a little bit more. Like, first, maybe say how, like, I guess, why it's important to do personalized medicine for children, for minors. But then this sort of thorny question of like, well, then who gets to really control that data for like maybe the 18 years plus, or 18 years max, that this individual is a minor.
Yeah, I think this is one of the biggest challenges facing our field. And over the last few years, you've heard a lot of talk about vulnerable populations, and certainly children, neonates fit into this. And it's been very important for me in my career to ensure that babies have a voice. And I've dedicated my career on all levels to making sure of that. As these technologies emerge, and I want to reiterate Latrice's point, it isn't always DNA. Sometimes it's clinical parameters, sometimes it's other biomarkers. So it isn't always that we focus in on DNA, and that makes it personal. But as the field has evolved for incorporating genetic DNA testing into babies, we've seen both the benefits and the pitfalls, and the things that we absolutely need to be so cautious, careful, and willing to address as we integrate this technology. On the one hand, I shared with you, we've seen this amazing ability to diagnose children so rapidly with these technologies that have directly impacted their lives, in some instances saved their lives. We have had babies who we've done rapid genomic sequencing on, understood the exact medicine they needed to have immediately based on their DNA, and have saved their lives. That's how impactful targeted personalized medicine in this population can be. The flip of that is it's someone's DNA. It is an enormous responsibility to sequence a human being, have that data available, determine where to store that data, and be enormously responsible of that data, particularly when the child did not consent to have it done. And the major issues we, of course, deal with are, first and foremost, adult onset diseases. What do you do with a child where you can predict, based on their DNA, they may get Huntington's disease, or they're at extraordinarily high risk for BRCA mutation leading to, they have the BRCA mutation, they can get breast cancer. What's the child's right to a free childhood without the burden of knowing or having parents know that that child may have a shortened lifespan, or that child is going to get very sick later in life, barring a treatment plan that may develop over the course of their lifetime? When should you tell that child? Should that child be able to come of age and make that choice for themselves? So this concept of a free childhood is very real, and we must take that with great responsibility. The other thing that we struggle with, of course, is in my world, when we do genomic analysis or DNA testing in babies, we often want parents. It helps us interpret. So we're not just sequencing a baby, we're sequencing their parents. And in our world, in the NICU, we know that up to 1 in 10 babies in a given nursery has what we call false paternity. It's not the right father. And how we handle that information is of great importance, because we know that your risk for certain diseases matters based on what you inherited. Who your biological parents are do impact your certain risks for lifelong health outcomes. That's why your internist asks you, has anyone in your family had cancer? Has anyone in your family had heart disease? And when we identify false paternity, the tradition has always been to look the other way, to not say anything, to let that family choose when they should share that information. But from a clinical standpoint, we have an enormous responsibility to ensure that that child does not give a false medical history, because that could have significant impact. So the field has to struggle with both of these issues, both the right to a free childhood and the right to know if false paternity has been identified. How we handle those issues, I think right now is a very critical moment for us in the field to ensure not only that we're providing the best care and making the proper diagnoses based on what we're finding, but as we've talked a lot about, it's about trust. If a child grows up and knows we withheld information deliberately, we saw what we believed was in their best interest in a very paternalistic manner, then we are greatly responsible for the betrayal they will feel. So this is really, in my mind, a very pivotal moment where we're balancing this amazing technology that certainly, as it applies to children, can have great impact, but comes with enormous responsibility that we simply just cannot turn away, run away, or ignore.
Right. I mean, this relates to one of the audience questions, which is how many aspects of this personalized medicine will be decided by the person who's affected, and how much of it will be decided for them, maybe from the care providers. And I guess, I mean, is that sort of maybe a case-by-case thing in your opinion, or do you sort of feel like there's a way that the individual patient can always have some sort of control over their own data?
For children, I think it's complicated. And in a perfect world, I'd love for their data to be safely stored in their own medical record, not their parents'. And they have the ability to, at 18, when they come of age, to unlock it. Not everyone wants personalized medicine, or this concept that we will sequence your DNA and we're going to tell you or try to predict what may or may not happen to you, or to try to guide care. That would be my idea of a perfect compromise, but that is a very complicated process to undertake, in large part by storage of data and where it goes and how the child would ever gain access to it later in life.
I guess quickly, and then we'll move on to another question that I would really love to ask all three of you. But do you think there should be a way that minors before the age of 18 should be able to make a decision about their medical data? I mean, if a child is 16 and needs to make a decision pretty imminently, if there's a situation like that arises, should they be able to unlock that data early?
Yes, of course. And I think with proper genetic counseling and their family, yes, I do think that. But I think it should be standard by 18, they have access to it.
Great. So you just brought up genetic counseling, which is an important resource in sort of integrating personalized medicine into communities, into care. And I want to ask the three of you, what is the best way that personalized medicine can integrate with sort of in an individual's care or with a community in a way that you see as ethical and effective? Latrice, do you want to take this one first, and then we'll go around?
Yeah, I'm just thinking about the question, I guess. So I like to disentangle. So I think one of the things that happens with personalized medicine is that we're talking about participation in generating the knowledge base. And that's separate than what might happen on the care side. So do you have a right to control your data and your data going towards a knowledge base about medicine and sort of biomarkers and that sort of thing? And also, do you have a choice about whether you want to receive the targeted treatments or biomarker therapies? Do you have a choice about whether you want to consent to or go see genetics services or see a genetic counselor where they may ask you to do a pedigree analysis and ask about sort of family history as a part of genetic testing experience? And so those are two different experiences that I think we're all involved in because of the nature of personalized medicine. I think right now, part of what I hear from Crystal, but I also know sort of some of the work that I'm involved in is I don't think there's enough autonomy, and go to sort of medical ethics and sort of the principles that we think about. I don't think we give patients enough autonomy over their data right now. I don't think that mechanisms are in place to ensure autonomy where your data goes. I think institutions, maybe your provider, if you seek care in a major academic center, may use that data for development, sort of R&D, they call it. And so that data gets used in different ways. It could also be that that laboratory test that got sent out, uses that data as well. That's essentially not exactly what happened with 23andMe, but essentially people gave their DNA for a test and it got used in different ways. It's this concept of broad consent that I think we don't have control over. The other side of personalized medicine is the care you get yourself and whether you have autonomy to participate in it at the level of the individual between you and your provider. And I will say that area, there's a little bit more autonomy, but there is one thing that I think we need to be very cautious about and very vigilant about as we think about moving personalized medicine forward and all the questions and things that need to be done to do that is, do individuals have access to personalized medicine so that they can make those choices? Will they be offered? I think is something that we have to think about, and we have to make sure that we're building a system that allows individuals to have autonomy in both areas.
Yeah. Jill, what about you? Is there a way that we can sort of help to integrate personalized medicine in a way that's going to really benefit patients and find a way to really allow people to benefit greatly from the power that personalized medicine can have?
Yeah, I think for use in newborns and children, it has to be absolutely targeted in a very purposeful way because they lack their own autonomy to choose this testing. And by that, I mean, we are not just sequencing every baby born. And some people have proposed that wouldn't that be great? Sort of Gattaca situation in reference to the movie where that comes from, where you would sequence every baby and know immediately what their life trajectory was. I don't think that's an ethical way to approach this. Rather, I think we could integrate it in the pediatric population when we are looking to find what is causing that child or that baby's symptoms. Understanding that, again, the weight of DNA testing is enormous. It comes with great responsibility, and we own both parts of it, the benefit of diagnosis and the enormity of the responsibility of having a child's DNA sequenced. But I firmly believe that in the pediatric population, it has to be targeted to those who are sick and who we are trying to find an answer that has eluded us.
Yeah. Crystal, what about you? I mean, you've talked quite a bit about, the difficulty to get communities on board with personalized medicine. Is there a way that we could integrate it in a way that would be positive?
I think one of the first things that we have to address are just structural barriers to even accessing any benefits of precision medicine, particularly in the communities that I work with. I work with a number of rural communities in which community members seek their care from the Indian Health Services. And just to give you an idea on just the level of disparity in terms of healthcare funding going into the IHS system versus like national per cap. Like in 2018, IHS funded something like a little over $3,000 per patient for the entire year. And that was, 2.4 times lower than the national average of healthcare spending per patient in that same year. So when we're talking about integrating the potentials of precision medicine into Indigenous communities, we have to address the fact that there are at this point, no Indigenous genetic counselors to even, provide an Indigenous patient and an Indigenous specific reading of their clinical test results. In fact, if an Indigenous patient wants to receive a genetic test, more than likely they will have to be referred out of their own institutions, their own home IHS facilities, to a healthcare institution, sometimes 3 or 4 hours away, one way. And whether or not that type of care is even going to be covered is a question. A lot of times the cost for genetic testing comes out of pocket for Indigenous patients, or, thankfully there are some very, I'm sure, 100% philanthropic clinical testing companies that will provide genetic tests to Indigenous patients for free. Not, of course, disclosing the fact that they have a commercial interest in collecting that information for themselves. So, and, just even putting a genetic counselor in Indigenous context is not the same as having a culturally competent genetic counselor within that setting too. So one of the things that I think is really important to think about is when we're talking about how to administer or provide a genetic testing opportunity to Indigenous peoples, is not only talking about the lack of specificity and perhaps in terms of detecting variants that's specific to their particular background, but also telling them about the importance of opting out of having their data being shared. And I think this is something that can be powerful and empowering for any community member, regardless of what community you come from, that as long as you understand that your data has value to someone somewhere, that you ask, is there a data opt-out policy, and what are my privacy rights as a patient providing this information. And I think that like everyone just having a direct more critical look at the informed consent forms that they're signing, or just knowing what they're implicitly agreeing to as a part of their point of care is really important.
Yeah. We've been talking a lot this night about a lot of the barriers in personalized medicine and things that kind of make it make this a challenging field to work in. But I know there's a lot of effort in personalized medicine. People are working with personalized medicine to try to make this field more equitable, to advance it and sort of help more patients have access to targeted therapies that can have really transformative effects for their disease or their health. So I was wondering if we could end with this question and I'll ask you this question, Latrice. Are there any efforts right now that you're aware of that seem to be really having some success right now in pushing personalized medicine forward and doing it in a way that's going to really benefit communities? And maybe if that's ultimately really successful, if you could say what that might do for the community in the future.
Yeah, I think it's a great question. One of the things I think it's important to understand is that this big idea has a lot of varied interests that are driving it forward. And I think we're still in a space where the commercial interests and sort of the things that make money, right? We're a capitalist society. Those are present and they're always going to be present. I think what we're trying to do, though, is push the community objective and the public health objective at the forefront to make sure that what we're doing right now in terms of investment of personalized medicine isn't all about commercial interests. Those are never going to benefit the communities. Crystal and I both work in communities. Jill and I works with communities where you have populations that you consider vulnerable, that you are concerned about being taken advantage of in this sort of paradigm. And so part of the efforts that I think are successful are the efforts that are really focusing on highlighting community interests, that are bringing communities together, stakeholders to have their voices heard as equal members of the table, to talk about sort of what they want and what they need. I've heard Crystal talk a lot about the Native Bio Consortium. I've seen a lot of the work that's coming out of that. I think that is a very powerful movement. I'm also involved with a sort of research initiative focused on building capacity where communities receive care. So that's building capacity for federally qualified community health centers. Crystal mentioned the population she worked with that are rural, where they can't get access to, some of this care, or the money allocated is not the same. I will say that we've also found in most major cancer centers are associated or near major cities where they have a large minority population. And we've done analysis at several and found that those populations that are literally right outside the door do not receive care at those academic cancer centers, right? And so this is a big issue. And so I think the initiatives that are being successful, whether it is sort of the highlighting of sort of communities that are potentially going to be disenfranchised, those who are currently being disenfranchised, being at a part of the table. The fact that this meeting right now has focused so much on this, right, as a part of a public forum, let's talk about the issues, not just the promise and the excitement, I think is a positive initiative. To talk about, there are initiatives moving forward, and I feel like I'm doing a disservice by not naming them and listing them all, but perhaps maybe a more sort of thoughtful and a thoughtful and sort of comprehensive way to approach it would be, I will send things to the Museum of Science and ask that Crystal and Jill as well, and then maybe we can put a comprehensive list together of what we think are the wins for communities in this overall sort of moment around personalized medicine.
Yeah, of course, I mean, it would take too long to try to list the very important efforts of everyone involved in this. But we only have so much time this evening, unfortunately. I'm sure we could talk about this all night. It's such a fascinating topic, and there's so much to dive into. But we'll end it here. I'll turn over the mic back over to Emily from the Museum of Science. Thanks so much for having us.
Thank you so much, Angus. Excellent job. Thank you so much for moderating. And thank you to all of our amazing speakers. I am so happy that you all were here. We learned so much from all of you, and I hope that we'll get to see you again soon. So big applause to all of you. You can go ahead and turn off your videos and wave goodbye to everyone. Thank you so much for all of that. All right, folks, so now we are going to move into the next half of our evening. For those of you who are joining us live on Facebook and YouTube, we will now stop streaming to those platforms. So thank you all so much for tuning in, and we